This is Auckland, one of two humanoid robots we have at AUT. And if you watch the robot walk with a keen eye, you'll notice something's not quite right. Watch it step to the left. That's what it should look like. Now to the right. See that? The steps are much smaller. It's like there's a limp, but the odd movement is actually causing a much bigger instability issue. In this episode, we're going to walk you through everything we tried to fix: or tires balance, IMU replacements, full motor calibrations, a visit from Unitree's own tech, and a moment where it just goes down completely.
When it steps to the left, it steps a lot easier, and then when it goes to the side steps to the right, it's a lot, moves a lot less.
But it's not just the walking. Watch what happens when the robot does something as simple as wave. That's a built-in gesture, it's not complicated, and it's stumbling heavily. This instability makes the robot unusable for the development that we plan to undertake. So we need to try and fix it.
We don't think it's the IMU, but we'll just replace it. That makes any difference. It more seems like it's a hardware issue, like the right leg for that. Nothing wrong with maybe the knee or the waist motor.
Unitree had already sent us a replacement IMU, the Inertial Measurement Unit. It's what tells the control system which way's up, how fast the body's rotating, and whether it's leaning.
Cool, so the G1 has two IMUs. One of them's up top here, and then there's one down in the pelvis as well. And so Unitree has suggested that we replace this one down here in the pelvis.
And it's the pelvis IMU that handles most of the balance data when it's walking. We've been holding off on fitting it, but at this point it's time to put it in. The access panel's on the lower front.
So what we want to do is just unscrew these screws and open up this casing, and then we can slot in the new IMU. And that's where the IMU is, just in there. Looks like it's just a clip.
The cables release with a small clip on each connector. Press in and pull straight back. The old unit comes straight out once the cables are free. The new unit seats back into the same spot, and the cables go back in the same order.
Yeah, so it just came with these ones, I think, just to show which cables connect where. I'm just clipping these ones in. Looks like it's pretty much good to go. Looks like I've got some kind of material here to prevent the vibrations getting to it. So that may help with the jittering issue that we had before. So it looks like that just pushes back in there. We're just putting the screws back in now, and we can turn the robot back on and test it, see if it's made any difference.
With the panel back on and the robot hanging in the gantry, we can power it back on.
The new IMU may need a calibration, as it's just straight out of the box, but Unitree hasn't said, so we're just going to turn it on and see what happens. And we can connect the robot through the app to see if any errors come up, which may indicate that there's something wrong with the new IMU, or if it needs calibration, but we'll see what happens. And we can see the new IMU that we replaced, the crotch IMU, seems to be reading pretty normal, so we'll go and put the robot into walk mode and see how it balances.
doesn't look promising, but we'll see what we can do.
So what I'll do is I'll get the app out and adjust the IMU offset, see if that helps at all. And then we'll keep changing the offset until we get it walking a bit more straight up.
The first thing we try is a calibration through the app.
There's a calibration we can do in the app here, and we need to hang the robot back up and use a spirit level to check that the shoulders are level. And then the other setting we can adjust is the offset configuration, so instead of actually calibrating it, we can change the offset after it's been calibrated. And we'll start with doing a proper calibration. If that doesn't fix it, then we can adjust the IMU offset configuration within the app.
This time we're doing the full process. Robot suspended in the gantry, spirit level across the shoulders to physically confirm the body's sitting straight, and then run the IMU calibration from that known reference point. This is the proper way to do it, and probably what we should have started with.
The spirit level needs to be this orientation so we can get the pitch and roll. Do you mind doing this real quick? Just when I say, can you press calibration start? I just got to get this level first. Yep. That.
Out of the gantry, and it's walking. I think it's improved, but the asymmetry is still there. It's still landing heavier on the right. So we go back into the app and try a few more offset adjustments. We're just trying to fine-tune our way to a fix at this point.
Just trying to change the offset configuration now to stop it tipping to the right. What's neat is that I can see the robot move in real time to check what direction it should be going, so I need to increase the roll.
Working on these robots doesn't always go to plan. Lucky they're pretty solid and there was no damage, but we've done everything we can. Calibrations, offset adjustments, replacing the IMU. This points to our original thoughts that it's likely something else, such as a hip or a leg motor. I think it's time to give Unitree a call. So we reached out to Unitree, the company in China that makes this model, and explained what we'd been through. Turns out they had someone who was already heading to New Zealand. What we didn't expect was that even the Unitree tech was calling back to the factory in China for guidance.
Okay, let's restart and do IMU calibration.
Okay, do we need to turn off phenomenal order?
He had the engineers on the phone while he was working through the calibration.
Dan, if you want to just start with calibration. I'm just trying to get the crotch IMU as close to 0 as possible.
His calibration approach was different from ours. Instead of using the spirit level to physically level the robot first, he was zeroing the raw sensor values directly in the interface. It's a subtle difference, but it suggests the process we'd been following wasn't quite the full picture. He ran a full motor calibration and a full IMU calibration, more thorough than anything we'd done on our own. They watched it walk for a bit and agreed it was still unstable. Then they pointed to the hip motors. We'd been wondering about that too, so we're happy their recommendation is to replace them. But the fact we're the only lab in New Zealand, that's not making this any easier.
So we'll replace these two.
Yeah, just do it.
And then do they think that is going to solve the issue?
Yeah.
Do they think that will fix the issue that we're having?
I think maybe we like to try. Yes, you can twist it.
Okay, yeah.
And I will give your step to me so you can unpack the result directly.
Perfect, yeah. And then if this doesn't work?
If it doesn't work, I think maybe eventually our technician come here.
Okay.
Our technician direct come here.
So that's where we're at. Unitree's sending us a new set of hip motors from China, and we're going to fit them ourselves. If you want to see how you pull a G1 humanoid robot apart and replace its hip motors, which doesn't go entirely smoothly, that's what the next episode's about.